In this clip, we're gonna study the concept of trunking. Basically, trunking is when we share resources. If we do share resources, then it turns out the efficiencies will be increasing. Okay, so let's look at this scenario where we there's a bank and the bank try to service customer. So let's look at the first way of managing customer, right? So there are three staff uh, that handle this cash transactions. So one person handle, deposit. The second staff handle withdrawal, and the third one handle foreign exchange. So you can see that for deposit, there are five customers who are waiting to be serviced by this staff member. On the other hand, there's nobody who's trying to withdraw money. So this staff is free, but he cannot service the other customer because they are in for different type of transactions. And for foreign exchange or forex, there are only two customer. Okay, so here this is where inefficiencies occur, right? Because these staff are, the bank's resource, but the way they manage their resource is not very efficient because they make sectors of this queue into three sector, and three sectors are, separate from one another. Okay, let's look at the second queue management, which is more effective. So instead of each staff handle only one kind of transactions, we make the staff to be able to handle all the transactions. It could be deposit, it could be withdrawal, it could be foreign exchange. Then and there's only one queue. Okay, so if any person that is finished with the customer, then the next customer can go into the next free agent. So usually we would see this kind of queue management in today's queue today's scenario. So this is much more efficient. Okay, so this is what we call trunking, where we apply trunking principle, where uh, the the resources are shared together, right, with one pool of customer. Okay. Now, in terms of cellular system, this is when we take a look at the cell that is service the users within the cell. So, for example, if the system has this target GOS, so remember GOS is grade of service with blocking probability less than 0.5%, or that is PB is less than 0.005. Okay, and it turns out there's 100 channels available per cell, and there's average traffic intensity per user is zero point 0.1 Erlang. Okay, so each person generate traffic at approximately or about zero point 0.1 Erlang per person, and there's 100 channels available per cell. So the question is which configuration support more user. Okay, so if you look at the first scenario is a cell with no sector. So what it means is there's a cell which can support 100 users, or there's 100 channels. There are base stations in the middle and it can connect up to 100 users at a time. Okay. Versus scenario number two. Okay. We have also a cell, but we're gonna divide this cell into 10 sectors. That means each sector will be allocated 10 channels. So again, we are given a cell, right? There's a base station, but this base station now has different set of antennas, right? So one antenna might point this way, and it can connect users only in these directions. And there's an antenna pointing this way, so it can connect user only in these directions only. Or there's an antenna pointing this way, and it can connect only user in in this sector only. And each sector can support 10 users. Okay, so imagine this is like you have one queue that can service everybody, but this one you have 10 different queues, right? Which different set of channels. So you can imagine that this is gonna be not very efficient, so this is gonna not gonna be very good. Okay, so let's consider no sectoring first. So remember the channels, number of channels is 100, and blocking probability is equal to 0.005. Now we want to find what is the traffic intensity, what is offer traffic intensity. Remember, we can model traffic intensity from Erlang B model. So we can use the formula, right? But in this case, it's easier to look at the chart, right? So recall this Erlang B chart where we have traffic intensity in Erlang, right? We have blocking probability, and we have the number of channels up here. Okay. So first, blocking probability is 0.005. So that means we are looking at this level of GOS, and the number of channels is 100. Okay. So where's 100 is this, right? So it means it's this straight line. Okay. Okay. So it's, you see that this is the point of interest, and if you look at the A here, right? Okay. So here's 100. This is 90. So this is 80. Okay. So A, or total traffic intensity, is equal to 80 Erlang in this case. Okay. This is getting from the Erlang B chart. Remember, traffic intensity per user is equal to 0.1 Erlang. So I use A with subscript U to denote traffic intensity per users. So that means the number of users that the system can support, right, is equal to, you take the total traffic intensity divided by traffic intensity per users. So it's 80 divided by 0.1, so it's 800 users. So this scenario can support 800 user with blocking probability less than 0.5%. Now, in terms of utilizations, right? So, what is the utilizations of the network resources? Actually, you can uh, look at the definitions of utilization. So, utilization is the traffic intensity that is offered to the network. So that's A divided by the maximum traffic intensity, right? So this is offer traffic intensity, right? This is in terms of Erlang. Okay, this is maximum traffic intensity in Erlang as well, right? And this is also equal to the number of channels, right? So each channel provide maximum traffic intensity of one Erlang, right? And then we convert it to 100%. Okay, so the bigger the number is, right, the bigger utilization is, it means that the network can use the resources uh, uh, very efficiently. Okay. Okay. So in this case, it's A, which is 80, divided by C, which is 100. So utilizations of the channels or the resources of the network is 80%. Okay, so it get used, uh, you know, it's get very good use. Okay. Now let's move on to the second scenario. Okay, right. This is when cell is divided into 10 sector. Now we're gonna consider each sector separately. So each sector provide 10 channels only, right? So remember, there's 100 channels, there are 10 sectors. So that means each sector only get 10 channels. PB is 0.005. So we want to find traffic intensity A, right? Again, we can use Erlang B chart, right? So let's get to the chart, right? So here is blocking probability of 0.5%. Okay. And remember, the number of channel is 10. So this is 9. So this is 10. So that means it's this curve, right? So if you look at this curve, uh, this is the point of interest. And if you look down to the A, right, this is A equal to 4, right? So this is 1, this is 10, right? And each That dashed line uh, indicate, right, the increase of one Erlang, right? So this is two, three, so that's the four. So that means A is equal to four Erlang. So the number of users supported in a sector, right? Remember, we consider only one sector, so it's 4 Erlang divided by 0.1. This is equal to 40 users. That means for the same cell, right? If we do this in terms of 10 sectors, uh, the total number of users that can be supported is 40 multiplied by 10, so it's 400 users. If you compare this with the number earlier where there's no sector, we can support more than a double, right? So that's 800 users. And when you do 10 sectors, it's only 400 users, right? And the utilization is only up to 40%. So the resource doesn't get used fully, right? Or as much. And the reason is because in the first scenario, there's no sector, right? We don't divide our resources into smaller bins, right? So we use 100 channels all together. That's the way to do it, right? That's more efficient. The reason that we have to do this 10 sector because we want to cut down interference, which you're gonna study in the next section or next clip. Okay. So for utilization, right, as the number of C increases, right? So if you have pool of larger number of channels, then you see that utilization increases as well.